Hello learners, my name is Mr. Paul Chilola once again, your teacher on this platform. Like I say all the time, this is your home. This is where you have to be, you have to visit all the time, not to play, but to learn, to prepare yourself for the coming exam. If you are in Form 3, preparing to study, to sit for the 2026 Msce exams, this is your home. This is where you are going to find all lessons in chemistry, physics, and other science subjects. So we continue with Form 3 chemistry with a topic called the experimental techniques. Experimental techniques covers a wide range of skills, chemical skills, chemistry skills, such as safe disposal of chemical wastes, analysis of substances in terms of determination of purity of substances, which we've looked at already. Now, welcome to experimental techniques, subtopic testing for water, ions, and gases. There are times when you shall need to determine if a substance contains water. How can you tell that a given substance contains water? Okay, so you carry out a test for water. You also be required to tell the nature and type of ions present in a solution. Right? Remember that ions are charged atoms. Charged atoms. What charged atoms are present in a particular substance? Examples of ions include sodium ions, copper ions, silver ions, iron ions, which can be 2+ or 3+. All these are called ions, and in particular they are called cations. Right? Or negative ions such as nitrate ions, sulfate ions, carbonate ions, and many other ions. You also be required to determine the type of gas which a substance releases, or a chemical reaction releases. The type of gas, the type and the name of gas released by a chemical reaction. So you're going to learn how you can test for the presence of gases such as carbon dioxide, hydrogen gas, oxygen gas, chlorine gas, and other gases. So that's basically what we are going to be talking about in this subtopic of the main topic, experimental techniques. If you're just joining us in this platform, once again, consider subscribing to the channel so that each time a lesson is uploaded, you're the first one to know. All right, so we are saying that chemists carry out different chemical tests in order to find out the identity of compound or gas. Okay, so that's what chemists do, including you, the chemistry student. You shall carry out different chemical tests. These are just small and short experiments to help you identify the name, the nature, the name, and the type of a compound or gas. All right, so you shall need to test for ions. You'll be required to test for ions or to test to determine the presence of ions. I mentioned earlier on that an ion is simply a charged atom. An ion is a charged atom. Ionic compounds contain two kinds of ions, namely cations and anions. The positively charged ions are called the cations. Okay? And the negatively charged ions are called the anions. The words cation and the anion originate from the fact that when you break down an ionic compound using electricity in a process called electrolysis, let's suppose that we have a solution such as say sodium chloride, which is salt, and then you pass electricity into the solution. If you pass electricity into the solution, something like this, you pass electricity into this solution, you pass electricity into the solution, or current, electric current into the solution. What's going to happen is that the sodium chloride is going to be split. All right? It's going to be split into sodium ions and the chloride ions. This is supposed to be Cl minus anyway. Okay, so if you consider this setup with respect to the cell or the battery used, a battery has, or a cell has, positive terminal and the negative terminal. The part of the battery which is, the circuit which is connected to the positive terminal of the battery is called the anode. It's called an anode, and that which is connected to a negative terminal is called the cathode. All right, so you learned somewhere that negative charges are attracted to positive charges, or unlike charges attract. So what is going to happen is the negatively charged chloride ions, which are negative nonmetal, will be attracted towards the positive terminal. For that reason, negative charges are called anode ion. okay, because they are attracted to the anode of the setup. So instead of saying anode ion, you simply take the first part, the AN, and then anion. Okay, sorry. Yes, you take the first part, the AN, and then you add this to ion. You form anion. Anion is a short way of saying anode ion. So instead of saying anode ion, you simply say anion, meaning it is the charged particle which is attracted to the positive terminal of this, of the what? The setup, the battery, in this case, the cell. In the same way, this terminal is called the cathode, like I said, and its negative is connected to the negative of the cell. So the positively charged ion, which is sodium in this case, we have just used the sodium chloride as an example, but it also applies to other ionic compounds, right? So this gets attracted to the negative terminal, which is called the cathode. So if you take the word cathode, and the ion, consider the first part, the prefix of the cathode name, which is cat, and then you add this to ion. It will form the name cation. That's where these names are coming from. That's very important. Okay, just for your knowledge. Eh? Okay, you may not be asked to say explain the origin of the names cation and ion. No, that's an inferior type of question. Okay, so that's basically what we are saying. So we have two types of ions. We have cations, which are positive, and anions, which are negative. So the ions are tested under aqueous conditions, meaning that these are tested when the ionic compounds are dissolved in water. Aqueous means watery, so they are water-based solutions. These are water-based. Okay, so the commonly tested cations, the cations that you are mostly going to be interested in to test will be calcium ions. Take note, calcium ions is Ca2+. The 2 plus represents its valency, or the combining power, which you might have learned in Form 2 chemistry. The 2 plus, or it is an indicator that it belongs to group number 2, calcium, okay, of the periodic table. Aluminium ion, which is Al3 plus, similarly, the 3 plus here represents the combining power. When it's combining with an metal, the number of electrons it loses. Then you have zinc and copper, as well as iron. There are two forms of iron. There is this one, which is called ferric. Don't mind these names. And ferrous. So ferric and ferrous have different combining powers. You have 2 plus and 3 plus. Okay, so what this means is that this element, iron, can form two possible ions. Okay, so the common ions, cations, that you are going to test, or you should be able to test, are these ones. Of course, there are times when you can have others like silver and the other cations that are intended for testing. All right, so testing for cations using aqueous sodium hydroxide. So the analytical substance we use here, the test reagent, is aqueous sodium hydroxide solution. Sodium hydroxide is NaOH. It's made up of sodium and hydroxide ions. This is Na plus and the OH minus. Okay, so this is used as a test reagent, a test substance. Okay, the one that is used for testing for the presence of positively charged ions, which are called cations. So how is this done? Okay, how is it done? I'll show you how this is done so that you can also repeat the same in your exams, practical exams. So when aqueous sodium hydroxide solution is added to various salt solutions, most of them form precipitates. Don't worry about the word precipitate. Precipitate is just a solid product. It forms a solid product. So some chemical reactions would form solid products. You mix solution A to solution B, and then a solid is formed. That solid is called a precipitate. Precipitate. Right, so, and then you also have some soluble complex ions. So we are saying you have these ions, you get a salt added to sodium hydroxide, the product is usually a precipitate. A precipitate precipitate is just a solid. The word precipitate should not overwhelm you or should not trouble you. And then you have another salt or a substance, a solution, which is a complex ion. And say ions. Okay, so this precipitate in most cases is insoluble, meaning it does not dissolve in water. Okay, all right, so the protocol or the procedure involved, which I'd love you to listen to very carefully. You simply add a few drops of aqueous sodium hydroxide solution, which contains to the solution that contains the cation. So let's say you have the test tube. Okay, so this test tube contains the solution which you suspect to contain a cation. So this is just a solution. Okay, so we are saying to this, you add a few drops. So using a dropper. Using a dropper, you add a few drops of sodium hydroxide. Okay, so add a few drops of sodium hydroxide, aqueous sodium hydroxide, to the solution that contains the cation, and then you observe, you note and record the color of any precipitate formed. Just using your eyes, you observe the color change. So initially, the solution can be colorless. This can be colorless, but then upon adding sodium hydroxide, you see a color change. So you note down the color change. The color change, it can be formation of a white solid or white precipitate. It can be green precipitate. It can be whatever color. You note down the color change. You record the color change in a table like this one here. So this table shows expected colors of precipitates and their solubility in excess of dilute sodium hydroxide. So we are saying that you have a sample, you add, so this is your sample in a test tube, to which you add the sodium hydroxide. Okay, so initially you add 3 of them. So 3 drops. Let's say a solution contains, a substance contains, you are testing a substance such as copper sulfate. So copper sulfate, which is CuSO4, contains copper ions, which is cation. It also contains a sulfate ion, which is a negative ion, an anion. All right, so when you add 3 drops of sodium hydroxide, the color that you are going to note down is blue, formation of a blue precipitate. Okay, now if you add additional sodium hydroxide, which is in excess means extra, so you're adding an extra sodium hydroxide, the blue precipitate still remains there, is insoluble. In other words, it's not going to dissolve, it will remain there. So the presence of the blue precipitate is testimony that there is copper ions in the solution. As simple as that. All right. If, on the other hand, this does not happen, let's say a blue precipitate is not seen, then that shows that the solution does not contain copper ions. So the presence of copper ions shall make the solution turn blue upon adding 3 drops of sodium hydroxide. And continuing to add more sodium hydroxide will not change anything. The blue precipitate will still remain there. All right? If you do the same with a solution that contains iron, okay, the test will show upon adding sodium hydroxide, you see a precipitate that is pale green, okay, something like faint green color. So you'll have a precipitate which is greenish. And upon adding more sodium hydroxide, the pale green precipitate still remains. Then that shows that this is iron chloride. I mean, the solution contains iron. Upon doing the same to solution of aluminium sulfate, for which the cation present is aluminium, you are going to have a white precipitate. So a white solid is going to be formed. Okay, so if you keep adding more sodium hydroxide, then the white precipitate is going to be dissolved. It is going to disappear. In other words, there's going to be a transitional color change from being white to colorless. So the white precipitate is going to dissolve and the color, the white color will disappear. Okay, but initially upon adding 3 drops of sodium hydroxide, you are going to have, or you will see, a white precipitate, which disappears upon adding extra sodium hydroxide. All right, if a solution contains magnesium ions, for example, magnesium sulfate is MgSO4, all right? So upon adding sodium hydroxide, you will have a white precipitate. Okay, so you see something like whitish, like flour, wet flour appearing in the test tube that you are adding this to. Okay, if you keep adding more sodium hydroxide, then the white precipitate will still remain. It will not disappear. Okay, it will not disappear. All right. You keep doing the same with the calcium sulfate, zinc sulfate. In both cases, you see white precipitate. But the difference it will make between the presence of calcium and the zinc is that upon adding extra sodium hydroxide, zinc, the white precipitate in the solution will remain insoluble for zinc sulfate, but for zinc sulfate, it will disappear. It's going to disappear. So we are saying in calcium sulfate, the white precipitate will remain there, but in a zinc sulfate, the white precipitate is going to dissolve. Make sure you know this table, because your Msce exams will not give you this chart for you to use in determining the type of cations present in the solution. All right, unlike other syllabi, like the Cambridge syllabus will give you this, maybe, perhaps in paper 6, which is an alternative to practical paper. They'll give you this chart for you to use in making inferences for test results of different cations and anions. All right, so my name is Mr. Pochilola once again. In case you have questions and I want to seek clarity, don't hesitate to leave a comment. We shall be able to come back to you to offer more explanation. Thank you very much for now. We meet again in the next lesson in the same topic of experimental techniques. Consider subscribing, invite your friends, wherever they may be, to come and join us so that they also learn at no cost. Thank you very much. Wishing you the best.